Right. For the process of electroplating and purification of metal, it is very important for us to position the metal and the object carefully. Alright, either at the anode or cathode. For the process of purification for the process of electroplating or purification of metal, at the cathode, we position the object or the pure metal. Alright, whereas for the anode, we position the electroplating metal or the impure metal. This one is depending on what process is being carried out. So remember, for cathode, if you are going to do electroplating, you must position the object that you're going to plate at the cathode. And if you're going to do purification, alright, the pure metal will be at the cathode. Now, for anode, the electroplating metal or the impure metal will be positioned at the anode. Now, for the aqueous solution, alright, must contain the electroplating metal ions or the purifying metal ions. Alright, now if we look at the half equation that takes place at the anode, so at the anode, as we studied earlier in the earlier topic, oxidation normally takes place at the anode. So for oxidation, the half equation here is copper atom donates 2 electrons to produce copper 2 ions. Alright, so observation, what we observe in the experiment will be the anode becomes thinner, or the mass, if we weigh the mass is reduced. The mass of the metal at the end of the experiment is reduced. Now, if we look at cathode, so the cathode undergoes reduction. So here, copper 2 ions receive electrons and change into copper atoms. So the observation will be it becomes thicker, or the mass of the metal increases.
Construction of an electrolytic cell. Do you know that electrolysis has various industrial applications, such as electrolytic refining of impure metals like copper, and the formation of artificial gold jewelry? Apart from this, it is also used in the charging of a rechargeable battery. Electrolysis is a process in which electrical energy is used to carry out a non-spontaneous chemical reaction. The apparatus in which electrolysis is carried out is called an electrolytic cell. Now let's construct an electrolytic cell for the electrolytic refining of impure copper. To do this, take the electrolyte of an acidified copper sulfate solution. Next, take a thick rod of impure copper that will act as an anode and join it to the positive terminal of the battery. Finally, take a thin rod of pure copper that will act as a cathode and join it to the negative terminal of the battery. When the switch is turned on, the copper ions receive electrons from the negative terminal of the battery and are reduced to copper atoms. The copper atoms are now attached to the crystal lattice of pure copper. In order to balance the deficiency the copper atoms created in the electrolytic solution, the copper atoms from the impure copper rod oxidize to copper ions. As a result, the concentration of copper sulfate is maintained inside the electrolytic cell. This process continues until all the impure copper gets deposited at the pure copper electrode. The impurities present in copper are deposited at the bottom of the electrolytic cell. These impurities are called anode mud or anode sludge. You have completed this activity. Select OK to return to the menu and continue to the next activity. Assess your knowledge. Follow the instructions to perform the assessment and earn points. You can try multiple times, but points are only awarded if you answer correctly on the first try. Click on the beaker containing the most appropriate electrolyte for the electrolytic refining of impure copper. Well done! You have selected the correct electrolyte required for the electrolytic refining of copper. Drag the metal rod that acts as an anode and join it to the positive terminal of the battery. Well done! You have successfully selected the impure copper rod as an anode. Drag the metal rod that acts as a cathode and join it to the negative terminal of the battery. Well done! You have successfully constructed the electrolytic cell for the refining of impure copper. Drag the copper atom from the crystal lattice of the electrode undergoing oxidation and drop it into the salt solution. Well done! You have successfully oxidized the copper atoms present in impure copper rod. Drag the appropriate ion and add it to the crystal lattice of pure copper rod to reduce it. Well done! You have successfully deposited pure copper atoms at the cathode. You have completed the assessment. Here is your score. You scored well, and you have completed the module. Select OK to return to the menu where you can exit.
Question. Choose the correct half equation for the iron key. Option 1. Ag ++ E. NGT, Ag. Question. The purification of copper by electrolysis is carried out with Option 1. Impure copper as the anode. Option 2. Copper as the cathode. Option 3. Impure copper as the cathode. Option 4. Copper as the anode. Question. Electroplate an iron ring with copper, Cu, copper anode. Option 1. Ionizes to become copper 2 ions, Cu2+. Option 2. Oxidizes to become copper atom.